Hello viewers, let us see the one more session today. In this session we will discuss classification of the elements. So what are the various classifications that are there and what are the fundamentals to the periodic table and classification we will see. Now a substance consisted of one kind of atom. Any substance that is having one kind of atom is called as an element. So the concept of element was introduced by Robert Boyle for the first time. So the Robert Boyle, when he introduced elements, the concepts of symbols, but the symbols for elements was developed by Berzelius, a great scientist. At present there are 118 elements are discovered. 118 elements are discovered. Among these, 94 elements are considered as naturally available one. Remaining elements are generally man-made for the purpose of various uh, uh, activities. Elements coming after 92 atomic number are known as transuranic elements. They are also said as synthetic elements or man-made elements, which are made in the factory. Total 11 elements are present in gaseous state, such as hydrogen, oxygen, nitrogen, fluorine, chlorine, and inert gas ozone is also a gas. So here some of the element composition, atomic weight and gradually given. Lithium with atomic weight 7, sodium 23, potassium 38. Element calcium having 40 atomic weight, strontium 88, beryllium 137, lithium 35.5, sodium 80, potassium 127. So in case of historical development, Dauberniers triad by the scientist called Daubernier, he made a group of 3 elements. They are having similar chemical properties called triad. Now the Daubernier triad atom weightage of middle element is equal to the average atomic weight of first and third element. In case of mean atomic masses, element atomic weight. Now I am taking lithium. I would like to give you one example for Daubernier triad. Triad means 3 elements must be there. Tri means 3. So the atomic weight, element atomic weight will be for lithium 7, sodium 23, potassium 39. Here, if you carefully observe, first element lithium, last element potassium. So let us combine atomic weight of lithium plus 39. If you divide it by 2, okay, 7 plus 39 means what will be 46. So 46 by 2 is equivalent to, okay, 46 by 2 equivalent to 23. So which is the atomic weight of sodium. So this is called as a Daubernier atomic triad system. Mean of atomic masses, elemental atomic weight can be measured by the mean atomic masses like this. Understood everyone? Now Daubernier's triad, some of them are given here in this table. If you take the element lithium and sodium and potassium, we have seen element calcium, strontium and barium. If you see that calcium atomic weight is 40, barium atomic weight 137, 40 plus 137, how much it is? 177 divided by 2, how much it will be? 88, isn't it? So chlorine atomic weight is 35.5, bromium 80 and iodine 127. Chlorine 35.5 plus 127. So divided by 2 equal to 80. It will be approximation value is given there. So whatever it is, Daubernier triad system explains, okay, the atomic weight of particular elements and their number. Finally, telluric helix. What do you mean by that? Kahn Cartels, a great scientist, arranged then known elements in order of increasing atomic weight. and made a cylindrical table of elements to be displayed, and periodic recurrence of properties. So in case of Newland's law of octave, another scientist, Newland, proposed on the sequence of elements on the basis of their relative atomic weight. Now, if elements are arranged in order of their increasing atomic weight, eighth element resemble the first one, the ninth element resemble the second one. So eighth element resemble the first one, ninth element resemble the second one, tenth element will be resemble the third element in the atomic periodic table. Newland compared his arrangement with the repeating musical octave. In a musical octave, as you are aware of it, sa, re, ga, ma, pa, da, ni, sa, that are the sounds that are commonly present in it. So sa, that is the first sound, and in a musical octave, seven musical sounds will be there. First one and third one ga, fourth one pa, fifth one da, okay, ni, sixth one, okay, again seventh one is going to be repeated. So here, if you carefully observe sarigama padanisa, which indicates in the place of sa in the periodic table, lithium will be there, re, beryllium, that is boron, third one, carbon, fourth one, nitrogen, fifth one, oxygen, sixth one, fluorine, seventh one. So eighth one is lithium and ninth one is beryllium. So in this order, if you carefully see, sodium, magnesium, aluminium, strontium, phosphorus, sulfur and chlorine will be automatically will be repeated. So the properties of lithium are similar to the eighth element, sodium and beryllium. So sodium, you can see here sodium, where it is there, sodium is similar to sodium and beryllium are similar to the magnesium and so on. So lithium are similar to the eighth element. Lithium is similar to the eighth element, sodium, magnesium and so on. All that gases are known as, hence all that inert gases are unknown, but hence this rule is valid up to only calcium. Finally, I am telling you Newland octave, element lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and element sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine, element potassium, calcium. Now lithium and atomic weight 7, sodium 23, potassium 39. This is the order of Newland octave. Newland octave by comparing with that specific musical octaves. Lothar Meyer, findings of Meyer are: alkali metals having the largest atomic volume. I am talking about volume. Volume is different now. The alkaline earth metals, magnesium, calcium, strontium, beryllium are best example for alkali earth metals. Occupy the midpoint position of the curve. In this case, halogens occupy position on, if you take the halogens, they occupy position on ascending portion of the curve in inert gases. Now, the transition element occupy the minimum of the curve. Now, finally, I am telling you Mendeleev's classification of element, periodic law. What is that? Let us see. It is also known as short form of periodic table. What is that called? Short form. If you want to learn the periodic table in short form. Mendeleev observed that elements with similar properties almost have the same atomic weight. Example, iron, ferrous 56, cobalt 59, nickel 59. So in this case, elements are arranged in 12 horizontal rows called series, which are grouped into 6 periods. So these series are going to be grouped into specific. Now specifically I am telling you group numbers I have given here. First group, second group, third group, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th. Okay. Representation of the group numbers 1A, 2A, that are also group numbers. Now In case of elements, if you see, and you can see the F, inert transition elements. Lanthanoids and actinoids are together called inert transition elements. Transition elements which are different from other things. So, first three periods are known as short periods and remaining were known as long periods. Each long period has two rows of elements. Vertical columns are called groups, and there are 9 groups from 0 to 9, leaving 0 and 7th. Each group is subdivided into subgroups known as B groups. So, group 7 of the Mendeleev's table consisted of 3 triads known as transition triads, and they are iron, cobalt, nickel, ruthenium, rhodium, palladium, osmium, iridium, palladium. Each and every element have some industrial properties. They have some economical use in our day-to-day life. They are used in making different articles in our day-to-day life. That I will discuss with you while discussing their properties. Mendeleevs have foresight to leave some gaps in the periodic table of each 3 elements. Eka boron, presently known as scandium, Eka silicon, presently known as germanium. So here Eka aluminum, presently known as gallium. Mendeleev corrected the atomic weight of beryllium, indium, osmium and beryllium by using corrected valency of elements. So atomic weight is equivalent to equal weight into valency. Now finally I would like to say that demerits of Mendeleev's theory. Some of the elements were placed before the lower atomic weight. To maintain the similar chemical nature are called inverted pair or anomalous pairs of Mendeleev's periodic table cannot be explained. Suppose example, argon to potassium, cobalt to nickel, beryllium to iodine, thorium to palladium are the best example which cannot be explained by Mendeleev with the lower atomic weight elements. Position of hydrogen was not made by Mendeleev clearly. Now finally, modern periodic law, present form of the periodic table. Present form of periodic table, we must bear in mind that Mendeleev developed his periodic table. Chemists knew nothing about the internal structure of an atom. However, the beginning of 20th century witnessed profound development theories about subatomic particles. Now in this case, in 1913, English physicist Henry Moseley observed that regularity in the characteristic of X-ray spectra of the element. Each element have the X-ray spectra. This spectra, a plot of where is frequent X-rays are going to be emitted. That character is called X-ray spectra against the atomic number, which means atomic number is linked to X-ray emitted character, that is nothing but X-ray spectra, gave a straight line and not the plot of versus atomic mass. But here thereby showed that atomic number is a more fundamental property of an element, which means its atomic mass, and Mendeleev's periodic law was therefore accordingly modified by the atomic mass. This is known as modern periodic law. Can be stated as the physical and chemical properties of the elements are periodic functions of their atomic numbers. What I am telling, periodic law revealed important analogies among the 94 naturally occurring elements, which means you know that 94 elements are naturally occurring, whereas neptunium and plutonium like actinium and protoactinium are also found in pitch blende and ore or uranium. Pitch blende, like a blend, it is available as an ore of uranium. So it stimulated renewed interest in inorganic chemistry has carried into the present with creation of artificially produced short-lived element. You may recall that atomic number is equal to the nuclear charge. Nuclear charge is nothing but number of protons or the number of electrons in a neutral atom. It is the easy way to visualize significance of quantum numbers and electronic configurations in a periodic elements. In fact, it is recognized that periodic law is essential for the periodic variation in electronic configurations. Whereas if you take physical chemical properties of elements and their compounds, numerous forms of periodic table have been dissolved from time to time. Now some forms of emphasis, chemical reactions and valences where other stress and electronic configurations of elements are also considered. A modern version of the law, so-called long form of periodic table of elements, is most convenient and widely used. Presently, we are currently using long form of periodic table. Horizontal rows are called, in which Mendel called series, are called as periods, and the vertical rows columns are called groups. Elements having similar outer electronic configuration in their atoms are arranged in vertical columns. And vertical columns are having elements with the outer electronic configuration in their atoms. They are referred as groups or families. Okay. Now, according to the recommendations of IUCN, the groups are numbered from 1 to 18, replacing the older notation. So 1A, 2A, 8th and 1B, 7th B and 0. There are altogether 7 periods. Remaining part I will discuss with you in the next video. Thank you. Have a nice day.